Okay, today we're looking at slopes of parallel and perpendicular lines. Typically, I would go ahead and write this on the board, draw it on the board, but today we're going to go ahead and look over at Desmos. So let's start with parallel lines, okay? And let's look at two um, horizontal lines, okay? That's where we have y is equal to a number. That will create a horizontal line, okay? And so we should recognize that we could change this line up. See, I'm just sliding this around. As long as we have two horizontal lines, they will always be parallel because they'll never intersect. Okay, so now let's go ahead and change this to vertical lines, which would be x is equal to a number. Okay, and so now you can see that these are also parallel, right? Because they'll never intersect and they're on the same plane. So any two horizontal lines are parallel and any two vertical lines are parallel. Okay, so now let's take a look at some non-vertical lines. So how about we do y is equal to 3/4 x plus 1 and y is equal to 3/4 x plus 4. Okay, so what we need to recognize here is that these non-vertical lines will be parallel if and only if they have the same slope. And that's the value in front of the x, this m value, right? Because the slope-intercept form would tell us that y is equal to mx plus b, where m is the slope. So this m value, right, the 3/4, that's your slope. So we can go ahead and we can change up our y-intercept. But we notice those are still going to create parallel lines, right? So here we go. We can do a negative. How about -4? So we recognize that we can change up the y-intercept, but as long as the slopes are the same, the lines will be parallel. Okay, so let's go ahead and write that down in our notes. All right, so we do know that two vertical lines are parallel and any two horizontal lines are parallel, so that's good. But let's also recognize a little bit more importantly for this lesson. Okay, so two non-vertical lines are parallel if and only if they have the same slope. Okay, so let's take a look at an example here. So what we need to do is write the equation of a line that is parallel to this line, y is equal to -3x plus 5, and goes through this point. Okay, so what we need to do for an equation of a line in slope-intercept form, we need y is equal to mx plus b. We need to find an m value and a b value, okay, or our slope and our y-intercept, okay? So all we're doing with this line here that they've given us is pulling out the knowledge that if the line that we need to write is parallel to this line, well, then we need to recognize that we're going to be using the same slope. Okay, so the slope of this line is -3. Okay, and if the line that we need to write the equation of is parallel, we need to use the same slope. Okay, so now we're done with this. We don't need anything else with that equation. Okay, so now what we're going to do is we're going to recognize that we were given an x and a y, and we have an m, right? So what we can do is plug those three numbers into our equation and isolate b, and then we've solved for it. Okay, so y is equal to 8. So 8 is equal to m was -3, times x, and we see x is -1, plus b. And now we just have to solve this equation, isolate b, and we have it. So -1 times -3 is +3. Right, now we want to get b by itself, so we subtract 3 on both sides, and we're left with b is equal to 5. All right, so the last step is to take our m and our b value and just plug it in to our equation. So we've got y is equal to negative 3x plus 5. Okay, let's move on. We've got a different type of question here. So are the following lines parallel? So basically what we need to do is get these into slope-intercept form, right? We need to make this look like this. We need to isolate y or solve for y, and then we just need to see if the m values are the same, okay? So I'm going to take the first one here. So I have 3x minus y is equal to 6, right? And I want to solve for y. So I'm going to subtract 3x. If I do it to one side, I have to do it to the other side. So I'm left with negative y is equal to, this is a good time to kind of switch the order here. Just remember, we can obviously not subtract 3x's from 6 1s, right? They're just not like terms. So we're just going to switch the order to put this in slope-intercept form. We've got negative 3x plus 6. And now we want to solve for a positive 1y, not a negative 1y. So this is really a negative 1 in front. So we're going to go ahead and divide by negative 1, because negative 1 divided by negative 1 is positive 1. So now I'm left with positive 1y. And if I divide it by negative 1 on the left side, I need to do so to all terms on the right side. And now I'm left with negative 3 divided by negative 1, which is positive 3. Drop down the x. Positive 6 divided by negative 1 is negative 6. And there is one of our lines in slope-intercept form. Now we're going to look at this line over here. We've got negative 6x plus 2y is equal to 24. So we're going to do the same thing here. We're going to isolate this y term. So I'm going to get rid of this 6x, negative 6x, by adding 6x to both sides. I'm left with 2y is equal to 6x plus 24. And now I divide by 2, divide by 2, divide by 2, and I'm left with y is equal to 3x plus 12. Okay, and so now we've got them in slope-intercept form. Are the following lines parallel? Why or why not? Well, yes, they are, because their m's, or their slopes, are the same. So we're going to say yes, they have the same slope. Okay? Okay, now we're going to jump back on over to Desmos to look at perpendicular lines. Okay, so now let's just take a look at about y is equal to 3 and x is equal to 4. So what we're going to recognize here is that if we have one vertical line and one horizontal line, those will be perpendicular lines. And just to remember what that means is that they create right angles. Their intersection creates right angles. So right here, that is a 90-degree angle. Here's a 90-degree angle, and here as well. Okay, so a vertical and a horizontal line are perpendicular. And let's look at some non-vertical or horizontal lines. So how about, I think we used 3/4 x, x plus 1. So let's take a look. Well, if we want to create a perpendicular line, I do recognize that this line here is going up. This is a positive slope. So why don't we try y is equal to negative 3/4 x plus 2. Okay, so that looks close. They're definitely intersecting in the right direction. One is positive, one is negative, but these are clearly not perpendicular lines, okay, because these are not right angles. So actually what we need to do is we need to switch the fraction. We just need to flip it upside down. So once we do that, hopefully we can recognize that now we've got nice, perfect right angles. So these lines create perpendicular angles if their slopes are negative reciprocals. Okay, so let's go ahead, jump back over to our notes and write that down. Okay, so two lines are perpendicular if and only if their slopes are negative reciprocals. Okay, and so an example of that would be if you have, let's say, -2/3, the negative reciprocal, or I always say the opposite reciprocal. Let's write that down. The opposite reciprocal would be, sorry, the opposite reciprocal would be +3/2. Okay? And then, as we mentioned before, vertical and horizontal lines are perpendicular. All right. So let's take a look at some examples here. Write the equation of a line that is perpendicular to, let's give about 1/5 x plus 2 and contains the point 15, -4. Okay, so again, we need to write out an equation, and we're going to need an m and a b, right, or a slope and a y-intercept. So let's first figure out our slope. Okay, so the equation of the line that we need to write is perpendicular to this line. Okay, and so the slope of this line is the m value. It's the value in front of x. Okay, so the slope of this is 1/5. So what we need to use is the negative reciprocal of this, which would be -5/1, or we could just say -5. Okay, so the slope that we need to use is -5. All right, and now we need to figure out our y-intercept, or our b. So we're going to take our slope-intercept form equation, y is equal to mx plus b, and we're going to plug in our x and y value along with our m, and then we can isolate b. So it looks like our y is -4 equals our m, which is -5, times our x, which is 15, plus b. And now we can go ahead and solve here. So -5 times +15 is -75. All right, let's update the problem. Just drop everything down. Now I want to isolate this b. So I'm going to get rid of this -75, and I'll do so by adding 75. If I do it on one side, I need to do it to the other side. So I'm left with b on the right side, and -4 plus 75 is +71. So there is our b, or our y-intercept. And then don't forget, the last step is to plug our values into the slope-intercept form equation. So y is equal to -5x plus 71. Okay. All right, now let's look at this example. Are the following equations perpendicular, y or y not? This was nice because the first one's already in slope-intercept form, so we don't have to do anything. We just need to recognize that our slope here is 4 for the first line, and now we're going to put this line that's in standard form into slope-intercept form. So we got 8x minus 2y is equal to 10. So I'm going to subtract 8x on both sides, and I'm left with -2y is equal to, let's switch the order here to put it in slope-intercept form, -8x plus 10, and now divide by -2, divide by -2, divide by -2, and I'm left with +1y is equal to Negative over negative is a positive 4x. And positive 10 divided by negative 2 is negative 5. Okay, so the slope here of this line is also 4. So are these perpendicular? No. Their slopes are not negative reciprocals, okay? Oops. No, their slopes are not negative reciprocals. In order for these to be perpendicular, one would have to be positive 4, one slope would have to be negative 1 over 4. Okay, but that's not what we have. We have the same slope, so actually these lines would be parallel. Okay, we're looking at the back side of 3.6, properties of parallel and perpendicular lines. So this first question here, we've got a rectangle is a quadrilateral that has opposite sides that are parallel and adjacent sides that are parallel. Is the quadrilateral ABCD a rectangle? Why or why not? And then we have these lists of points here. So what I would do is just graph out a rough figure here. So I'm going to give myself a little bit more room here. So I'm going to give myself an X and Y axis. Here's my Y, here's my X axis. Okay, so 0.11. Let's give us some. Okay, here we go. So A is at 1, 1. That is right here. That is 0.11. B is at 5, 3. So 1, 2, 3, 4, 5, up 3, 1, 2, 3. And again, this doesn't really have to be perfect. We just want kind of a rough figure here. And point C is at 7, 1, 1, 2, 3, 4, 5, 6, 7, up 1. And D is at over 3, up 0. 1, 2, 3, up 0. Okay, so here we go. And don't just go based off the look here, because I know I went pretty rough here. So and let's label these points too. So this is 3, 0, and this is 7, 1. Okay, so basically what we need to recognize is that, let's also add these. This is A, B, C, and D. Okay, so basically what we need to recognize is that in order for this to be parallel, segment AB and segment DC have to be parallel, as well as AD and BC. So both of these need to be parallel in order for this figure to be a parallelogram. So let's just figure out our M values for each of these, and we can determine whether or not this is a parallelogram. So what we're going to do is use our formula to find slope, which is y2 minus y1 over x2 minus x1. And so we can label these points out: x1, y1, x2, y2. And we just plug them into the formula. So it's going to be 3 minus 1 over 5 minus 1. We can go ahead and solve here. 3 minus 1 is 2. 5 minus 1 is 4. And so 2 over 4 reduces down to 1/2. And then we can do the same thing for DC. So DC, that's going to be 1 minus 0 over 7 minus 3. And we get 1 over 4. And okay, so already actually, guys, we can stop, okay, because these are not parallel, okay, so, or they're not the same. So if their slopes are not the same, well then AB and DC are not parallel, okay, but we might as well just go ahead and do this out. Let's do DC and BC as well, just to see. Find BC, the slope of BC. I'm just going to plug it into the formula, so that's going to be 1 minus 3 over 7 minus 5. So we're left with -2 over +2, which reduces down to -1. And AD will do the same thing. So 0 minus 1 over 3 minus 1. And we get -1 over 2, which is -1/2. These are also not the same. So yeah, this is definitely not a parallelogram. So no, it says why or why not. So no, their slopes are not the same. Okay, there's only one question like that. Don't freak out too much about it. I'm telling you, if you plot it out, it makes it a lot easier. All right, so pause the video, give these two problems a shot. We're looking for equation of a line that passes through these points and they're parallel or perpendicular. So remember, to write out an equation of a line, you need an m value and a b value. All right, for both of these. All right, pause the video, give them a shot. Okay, hopefully you get the same answer as I do. Let's see. So number one, we need to write the equation of a line that passes through this point 1, -5, and is parallel to the line y is equal to -9x. Okay, so all we're doing with this line is pulling out the knowledge that the m value is the slope, which is -9, and if the line we need to write is parallel, well, we're going to use the same slope. All right, now I'm done with this line. That's all I use that for. I'm done with it. Okay, so now we need to recognize I have an x, I have a y, and I have an m. Why don't we take the equation of a line in slope-intercept form and just substitute everything out? Okay, so y, we have -5, is equal to -9 times x, which is 1, plus b, and all we have to do is solve this equation. We just need to solve for b. So we're going to multiply this out. -9 times 1 is -9. Drop down everything. Now we want to isolate b, so I need to get rid of this -9. So I'm going to add 9. I do it to one side, I got to do it to the other, and I'm left with b is equal to +4. Now, we're not done here. We need to, the final answer is to write an equation in slope-intercept form. So what we need to do is say y is equal to -9x plus 4. That is the equation of our line. Okay? All right, number two. We're writing an equation of a line that passes through the point -3, 2, and is perpendicular to y is equal to 3x minus 4. So again, all we're doing with this line is pulling out the knowledge that the slope that we need to use is perpendicular to this one. So the slope for this line is 3. So we need a slope that's perpendicular. So 3 as a fraction is 3 over 1. If it's perpendicular, we need to use the opposite reciprocal or the negative reciprocal. So we're going to use -1 over 3. Reciprocal is just when you flip the numerator and the denominator. So we're going to use the slope of -1/3. And now I'm done with this line. Okay, now I'm going to use my m value, this x and this y. We're going to plug it into our equation and isolate b. So y is equal to 2, m is equal to -1/3, x is equal to -3 plus b. All right, -1/3 times -3. You can use your calculator on this, but negative times a negative is positive. This is going to equal +1. All right, let's update the problem. Drop down the equal sign of the 2 and the b. So I want to isolate this b. That means this +1's got to go away. I'm going to go ahead and subtract it. Do it to one side, got to do it to the other. I'm left with b is equal to 1. And the last step, put this into the equation. Y is equal to -1/3 x plus 1. And now you're done.